Hi YouTube, Timothy Unkert here. In this video, I'm going to go through a quiz review for an intro level logarithms type quiz. So if you're getting ready for that, this might be helpful. Okay, let's start. So we have log the base of 2 of 32 equals x, and we want to solve for x. So what we want to do here is first make sure I've got a marker selected. And then I want to write this in exponential form. So I'm going to write this as 2 to the x power equals 32. And I want to figure out how many times how many 2's I have to multiply together to get 32. So let's work it out. So we have 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32. So I have 1, 2, 3, 4, 5 2's. So 2 to the 5th power equals 32. So therefore, x must equal 5. All right, let's go to the next one. So this one we have log base 8 of 32 equals x. We want to solve for x. Now if we were to write this in exponential form, we'd write 8 to the power of x, so the base to the power of x equals 32. But then we would have to figure out what power of 8, how many times do we multiply 8 together to get 32? Well, we can't exactly get 32 if we're multiplying 8, so this is going to be a fractional power here. So what we really want to do is we want to use the change of base rule. So I want to rewrite this as log, so I'm going to say x equals some log with a base we don't know of c of 32. We'll figure out what c is in a moment, over another log with a base of c of 8. Okay, so what should c be? Well, c should be some number that we can multiply by itself enough times to get 32 and 8. And that number happens to be 2. So we're going to do log with a base of 2 of 32 and log with the base of 2 of 8. So how many 2's do I have to multiply together to get 32? Well, if I do 2 times 2 times 2, that gives me 8. So I have to keep going. Times 2 is 16. Times 2 is 32. So 5 2's. So the top part is going to be 5. Like we said, if we multiply 3 2's together, so 2 times 2 is 4, times 2 is 8. That's going to be 8. So the bottom is 3. So our solution here is x equals 5/3. All right, let's keep going. All right, so this next one, problem 3, we're going to evaluate the logarithm with the base of 16 of 1 over 64. So what that means here, what I'm doing here is I'm going to find out the numerical value for this. So I'm going to use the change of base rule. So I'm going to say log, and I want to pick some base some number that I can multiply by itself that will equal 64 and 16. And that number, the largest number that we can pick is 4. So I'm going to say log base 4 of 64 over log base 4 of 16. Now you could have also used 2 as your base, and then once you got a fraction at the end, you just have to reduce it. And I'm writing this quick because it's the end of the day, but the top part is actually 1 over 64. So sorry, didn't mean to confuse you there. Okay, so how many times do I multiply 4 by itself to get 64? I do 4 times 4 times 4, which is going to be 64. Right? So 3 4's. So if this were just 64, I would put 3 on top. But because it's 1 over 64, it actually is a negative exponent, so it's going to be negative 3 on top. And I'll leave a card to a video, should be up above here somewhere, on negative logarithms, because I have a video on that in case you're interested. Okay, this second one here, or the bottom part, we want to figure out how many 4s do we multiply together to get 16. Well, if we do 4 times 4, that does equal 16. So the bottom here is going to be 2. So our solution here is negative 3 halves. Cool. All right, let's keep going. Next one, we're going to evaluate the log with the base of 1/2 of 1 over 32. Okay, so that means how many times do I multiply 1/2 to get 1 over 32? Well, if I do 1/2 times 1/2, so multiply across the numerators, the 1s, you still have 1 on top, over 4. So that's 1/4. Keep multiplying. This is 1/8. Keep going. This is 1/16. Keep going. Well, now we have 1 over 32 when we multiply 1/2 5 times. So the solution here is 5. All right, let's keep going. This next one, we're going to evaluate the log, the base of 5 of 100. So we're going to use change of base. And normally I would advocate to find a base, a new base, that can be multiplied by itself a certain amount of times to equal 100. So maybe like you pick 10, but if you pick 10, you can't multiply 10 by itself to get 5. So I'm actually just going to use plain log, which has a base of 10 of 100. And we're going to divide that by a regular log. Again, this is a base of 10 of 5. Because we don't have a base that really works here. You could also do natural log of 100. The base doesn't really matter. You're just going to enter this into a calculator over the natural log of 5, and you're going to get the same thing. And when we do this, let me take out a calculator here. So we're going to do log of 10, log of 100 divided by the log of 5. And we get approximately 2.86, whichever one you use. So I'm going to say approximately 2.86. Okay. Next one. We have log base x of 27 equals 3. So I'm going to write this in exponential form. I'm going to say x, base of x to the third power equals 27. So what that means is that if I multiplied whatever x is by whatever x is by whatever x is, that would equal 27. Now in this case, we can try a few different numbers. So if we do 2 times 2, that's 4, times 2 again, that's 8, that's too low. Let's say we jumped up to 4. If we do 4 times 4, that's 16, times 4 again, that's 64, that's too high. If I do 3 times 3, that's 9, times 3 again, we get 27. So x has to be equal to 3. There is something you can use, which is a cube root. So I could do the cube root of x cubed, which is just x, equals the cube root of 27, which would give me 3. But I encourage you to play with the numbers. It gives you better number sense when you do it that way versus just always defaulting to a calculator. Okay, let's keep going. Next one, we have a log with the base of 5 of x equals 2. So let's write this in exponential form. So I'm going to write the base 5 to the power 2 equals x. So that means we multiply 2 5s together. So 5 times 5 equals x. 5 times 5 is 25. So 25 equals x. And we finished that one. Okay, problem 8. Log 6 of 1 over 216 equals x. So let's write this in exponential form. So I'm going to do 6 to the x power equals 1 over 216. So first off, I want to figure out how many 6's I need to multiply together to get just regular 216. So if I do 6 times 6, that's 36. Times 6 again, that's 216. So 3 6's. But again, this is 1 over 216, so we're going to use the negative exponent. So 6 to the negative third power equals 1 over 216. So x equals negative 3. And that's our solution for that one. Next one, we have a log base 2 of x equals 6. We're going to solve for x. So we're going to write this in exponential form with our base 2 to the 6th power equals x. So that means we have to multiply 6 2's together. So 2 times 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2, well, that's going to be 64. So 64 is equal to x. Okay, next one. We have log with the base of 64 of 16 equals x. I'm going to use the change of base formula. I'm going to say x equals log, and the biggest common base I can use between these two, where I get whole numbers on both the top and the bottom, is going to be 4, because 4 squared is 16 and 4 cubed is 64. So I'm going to say log the base of 4 of 16 over log with a base 4 of 64, and then we're going to evaluate. So 4 times 4, 2 4's multiplied together equals 16, so the top is going to be 2. And then 4 times 4 times 4 equals 64, so that's 3 4's multiplied together equals 64. So the bottom is 3, so our solution here is 2/3. All right, next question. Can you use NL for the change of base rule? So you might be thinking natural logarithm is abbreviated NL. It's actually abbreviated LN on the calculator. And that basically means you have a log with a base of E, which is a special number in math. You can use this, but not this. So the answer is actually no, but you can use ln, okay, which is log base E. All right, problem 12. Can you use pi as a new base for a change of base rule? Yes, if you put that into decimals, it still gives you the same result if you do the change of base rule with the log of base 10 or use natural logs. So the answer to this is yes. Hopefully you enjoyed my quiz review. If you did and it helped you out, please like and subscribe. And any questions, leave comments in the comments below.